All right, so welcome to problem number 5. This problem is going to be about gas laws and it's going to be a little bit shorter than the other videos because it only has one section to solve for. So problem says the following. The volume, pressure, and temperature of a gas are interrelated and adjust in response to changes in the other parameters. A balloon which can hold a maximum of 1000 centimeters cubed of nitrogen before bursting contains 955 centimeters cubed of nitrogen at 5 degrees Celsius. And we're asked to determine whether the balloon bursts or not if the temperature is increased to 30 degrees Celsius. For this, we're going to use the relationships between gas variables and the proportionalities that exist between them. There is one mathematical relationship between volume and temperature of a gas, which states that if you divide your initial volume by your initial temperature, that's going to be equal to your final volume divided by your final temperature. So now let's look at the problem and see which of these variables we are given. Now let's look at initial volume, for example. The initial volume, we are given a value of initial volume. It's 955 centimeters cubed. So that variable, we can give it a numerical value. The initial temperature is also given to us, which is 5 degrees Celsius. So that initial temperature variable can also be given a numerical variable. Now, final volume, we don't have. Final volume is not given to us. In fact, we need to determine the final volume to see if it is less or more than 1000 centimeters cubed, so that then we can establish whether the balloon bursts or not. So that variable is going to be the variable that we will be solving for. Now, final temperature, we are given as well. Now, the final temperature of the balloon is 30 degrees Celsius, and based on that temperature, we need to see if the volume is holdable by the balloon or not. So final temperature can also be given a numerical value. So without further ado, let's just plug in the numerical values we have and solve for that final volume. We are given an initial volume of 955 centimeters cubed, and one might ask, hey, why aren't you transforming to decimeters cubed? And that is a totally valid question. However, it's important to note that our final answer of whether the balloon bursts or not is going to be based on data that is given to us that is in the unit of centimeters cubed. So for this, it is appropriate to conserve our units as centimeters cubed, as it will be easier for us in the end to determine whether the balloon bursts or not if our answer is given in the same unit as the data that is provided to us by the exercise. So we'll just leave that 955 as centimeters cubed and go ahead and plug it in as our initial volume. Now, our initial temperature is 5 degrees Celsius. This temperature must be transformed into the standardized temperature unit for gases, which is degrees Kelvin. So in order to do that, we add 273 to that temperature. We add 273 to that 5 degrees that is given to us. So our initial temperature looks as 5 plus 273. That quantity, that addition, is our initial temperature in degrees Kelvin. So the right side of the equation looks like 955 divided by the quantity of 5 plus 273. Now let's look at the right side of the equation. Final volume is the variable that we're looking to solve for. So we'll just leave that as a variable. Now, final temperature, we know it's 30 degrees Celsius, but again, the standardized unit for temperature in gases is degrees Kelvin, so we need to transform that 30 into degrees Kelvin. And in order to do that, we just add 273 to that 30. So the right side of the equation looks like final volume divided by the quantity of 30 plus 273. So our total equation looks like 955 divided by this quantity, which is 278, is equal to final volume divided by this quantity, which is 303. If we make this operation of 955 divided by 278, we get 3.44. And in the right side, we keep getting final volume divided by 303. We move that 303 to the other side, multiplying, and we get that final volume is 3.44 times 303. Now let's remember that the value we are obtaining here is in centimeters cubed, so that it's easier for us to determine whether the balloon bursts or not. So if we run all this mathematical operation and calculate it, we get that the final volume is equal to 1042.32 centimeters cubed if the temperature of the balloon is increased to 30 degrees. Now, 1042.32 is greater than 1000. So, as the final volume, if the temperature is increased to 30 degrees Celsius, is greater than the maximum holdable volume of the balloon, it will burst if the temperature is increased to 30 degrees Celsius, as it is impossible for the balloon to hold it. It overpasses its maximum volume capacity. So that would be the end of this problem. I hope you learned about gas laws, proportions, and relationships between variables. And again, the presentation is linked in the description if you find that useful. Thank you.